All right, I am recording. Right now, there's nobody on. I can understand it with the weather and everything that's been going on. Let's see. It looks like Donald might be coming in. Donald, are you there? Can you hear me, Donald? Looks like your mic is muted, so.
Hello, can you hear me?
Yes, I can. Now I can. Michael, good morning. Can I hear you? Can you hear me? Can you hear me, Michael?
Yes, I can now. Sorry, I was
Okay.
having some issues here.
No, not a problem. All right, I am taping. Am I right in assuming that you can both on your screen right now, either one of you can answer, see the mail that I just sent out, Teams URL, and for today?
Yes.
Yes, sir.
All right. So as it says, that was the URL, and today I'm going to be going over Chapter 8, which is arrays and collections. Now, before I do, I want to come up to here. Now, my hope is that you can now see the schedule that I've been putting up here. All right. And this is where we are right now. We're Thursday. Lecture Chapter 8, if time, go over selected problems. All right. We're going to go over most of Chapter 8 today, maybe not all of it. Whatever we don't get to, we'll go over tomorrow because tomorrow is a much simpler chapter. All right. Also, and I should have moved this up, but I wrote a couple notes because I want people to know this. I will be grading all weekend, promise. I should have all of your work graded, everything that you've turned in by Sunday. I should have it graded by Monday, and it should be out there, and it should be on Inside Rankin. That's the first thing. The second thing, as it says right here, I will be making a recording this weekend of the test that you were supposed to take yesterday, the hands-on test. All right, for chapters 1 to 7. And I will email all of you a link out once that tape is finished. As it says, since it's a test, I'll make it available as a Teams URL, but I'm not going to put that out on the YouTube channel. Finally, so again, today is Chapter 8. Whatever we don't finish today, we will finish tomorrow along with Chapter 9. Next week, the plan is that we will, as it says right there, and I thought I changed, well, we'll see how this works. If we have to push this down a little bit, we'll do so. All right, I was going to give one lab and then give a pretest on Tuesday of next week, and then Wednesday would be the hands-on test. Now, you might think, man, you're really pushing through this stuff quickly. We're going to slow it way down after we get through Chapter 11, because chapters 12 through 16, I think I've mentioned this before, are amongst the hardest in the book. All right, so we're going to have to slow it down then to take some time, and we're going to be doing a running example, a running program that we'll be working on when we get to chapters 12 through 16. All right, so with all that said, I'm going to jump into as soon as I can find it. I am going to jump into going through Chapter 8. Now, can one of you answer me? Can you see Chapter 8 up on the screen right now?
Yes, sir.
Okay. All right. Now, I'm gonna quickly go through something, and for you, unfortunately, the two people who are here, Donald and Michael, you probably heard a lot of this last year, but I want to do it anyway for those people who have not heard it. All right. So what I'm going to do is I'm going to open up a new tab here, and I'm going to assume for a minute. Well, when I moved here now about 6 years ago, for the first 2 years I was living here, I lived in an apartment in Lake St. Louis. All right. And now this wasn't the address, but I'm going to assume that I was at 123 Main Street in Lake St. Louis, Missouri. I don't even know if there is a Main Street, and it's okay one way or the other. Missouri, 63367. Well, the point is this. Where I moved to, honest to goodness, it was an 8-family apartment complex. So I was in apartment 1, there was an apartment 2, apartment 3, apartment 4, 5, 6, 7, and 8. And the reason I'm doing this is we're going to pretend for a second. Like I said, I was in apartment 1. I didn't know any of my neighbors, but I'm going to assume that in apartment 2, there was somebody in there named Jones. In apartment 3, there was somebody in there named Smith. Apartment 4, somebody named White. Apartment 5, somebody named Black. Apartment 6, somebody named Green. Apartment 7, somebody named Brown. And apartment 8, all right, somebody named James. All right. So I'm assuming that right now. I don't care about first names. Those are all last names right there. And like I said, that's what I'm assuming. Now, you're all smart enough to realize that typically if somebody went out and sent an email or a USPS mail to Jeff Scott at 123, I'll just grab this. There, I get it. The post person would go in and look at all of the names that are on there, and they would put it in mine, even though it didn't say it here, apartment number 1. All right. Now, if it said that, that'd be even more information. Now, what if it said this? I might get it. Jones might get it. While I was living in the apartment, I occasionally got mail for the person who lived next to me or above me or whatever. It didn't matter. All right. So that kind of stuff happens. All right. And I think everybody gets it. Now, where I live right now, I have got a home in Lake St. Louis. And all kidding aside, I didn't find this out till I'd been there almost a year. But before I bought it, it was a rental home, meaning that a lot of people had lived in it through the years. Now, I've been there in May of last year, it was 3 years. So I've been there now 3.5 years plus. And I'm still getting mail for the people who used to live there. So let's say that I was going to go and create something and I was just going to call it apartment. And I wanted to basically say something like, in apartment number 1, we've got Scott. And, we can keep going here. So I could go and copy this down. I think you get the idea. In apartment 2, Jones, in apartment 3, Smith, etc. I could do that. Well, how would we do that programmatically? We'd come in here and we'd say something like this. Hold on. All right, John, hopefully you can hear me. We've started up. All right. So I'm coming in here and I want to create an array that's going to hold all of these different names. Okay, and I'm going to show you at least a couple of ways of doing it. First, I could say string, bracket, bracket, apartment. I could just do that, just like that. And that would create a brand new array, all right, that was called apartment. Now, that works just fine doing something like that in a language like JavaScript that we used last semester. You can't do that like this in a language like C# because it needs to know how big is this array supposed to be. So I would say something like equals new string Good morning, Clayton. We've just started up here. So we're creating a brand new apartment, a string of people that are simulating me back when I lived in an apartment. So to do this, we're saying string, which is the type, bracket, bracket, which means it's an array, apartment equals new string, and I could give it here a size. You can see that there are 1, 2, 3, 4, 5, 6, 7, 8 in there. All right. Now, if I did that, I would have one location called apartment, and each one of those locations, so there would be a string 0, and I can keep going, a string 1, a string 2, a string 3, etc. All right, but they would all be empty. So I'd have 0, 1, 2, 3, 4, 5, 6, and 7. But as of right now, just setting it up the way I've set it up right there, it would be as though I said equals double quote like that. And I did that again. So what I'm trying to get across to you is if I create what's called an array, it says I'm going to have a bunch of strings. They'll be referred to, and I screwed up here. That shouldn't be string 0. It should be apartment 0. So we'll change all these. All right. So this would be a brand new what's called an array. And what an array is it's a bunch of contiguous locations in computer memory. It's a little more than that, and we'll get into that in just a moment. Now, the name of this array is apartment. It has what are called 8 different indexes. You could look in a way at an index, it's like being a mailbox. All right. And index 0, as we use the ones that are in here, we could come in here and say that was Scott. Apartment 1 was Jones, etc. You get the idea. Now, when I moved into the apartment, there were people who moved in after me. There were people who were there before me. All right. So in other words, what I'm assuming here is if I do this, I'm creating what's called a new array. An array is a data structure. So in other words, it's a variable that can hold multiple values. This particular array can hold 8 different values. Each one of those values is a string. All right. So we put the type here, and we put the type here, and we put brackets here to signify empty brackets rather to signify this is going to be a string array. This is its name, and this is its size. All right. And the way you typically read this is either array sub, which is short for subscript, array sub 0 equals Scott, array sub 1 equals Jones, etc. Or you say, not array, apartment sub 0 equals Scott, apartment sub 1 equals Jones. Or you would say apartment index 0 equals Scott, apartment index 1 equals Jones. Either one of those would work. All right. Now, I want to show you another way we could have set this thing up, because you'll see it both ways. Right here, I'm assuming that they're very well, I'm going to put in here dot, dot, dot. And what I'm assuming is there's some code in there. I don't know what it is. I don't care what it is. But I'm assuming that when I create this array right here, I don't know the 8 strings I want to put into it. That's why I'm initializing it like this, because then it becomes an array with 8 empty strings in it, that double quote, as I showed you earlier. What if I do know those 8 names right away? Well, then I can do this. I don't even need any of this stuff right here, but I can come in here and I can do this. And I can say it's equal to Scott, Jones, Smith, White. I'm going to run out of room, so I'm going to put it on a new line, which is perfectly acceptable. Black, green, brown, and James. So what I'm trying to get across to you and what I'm trying to show you right here is the act of being able to create an array. Now, three of the 4 of you watching this right here, and Johnny, I'm sorry, you're the one odd one, so to speak, because you didn't take the AWD1000 class yet. When we did this last semester in JavaScript, you could go in and you could make this bigger. You didn't have to give it a size. You could go in JavaScript and say something like, string apartment equal bracket bracket, and that would have made a brand new array. In fact, you wouldn't even have to say string. We would have said here probably let apartment, and then we could have started filling it up like this. Now, why am I telling you that? Because in JavaScript, all right, you don't even have to give it a type. So in other words, I could have put in here Scott, then I could have put in here 37, then I could have put true, etc. You get the idea. I can mix data types. So that'd be a string, that'd be a maybe an int, that would be a Boolean, and I could have, for example, a double or a decimal. So I could mix all those. You cannot do that in C#. JavaScript is what's called an untyped language. It allows you to be very liberal in what you do. C# is a typed language. What that means is, since I'm saying that the name of the array is of type string, I can only put strings in there. If I came through there and tried to replace Scott with 37, I get an error message because I'm trying to mix types. I'm trying to put a numeric type into a string array. Okay, so again, although we could do something like that, something similar to that in JavaScript, you cannot do that in C#. The other big difference is once you create an array and you give it a size, in C# the size cannot change. So up there we said that it was called apartment and it could hold 8 strings. That's all it can ever hold. If I want to go and put more in there, then I've got 2 things I can do. I can either make a new array and copy everything over and add things to it, or as you'll see either later today or tomorrow, you can create something, not an array, but that's called an array list. The main difference between an array and an array list is an array list is dynamic. That means it can grow and shrink as the program's running. An array cannot do that. And I'm going to give you some terminology that you may or may not care about. But I'm going to use 2 words here. Early binding, and then in fact, I'll use 2 more. I'll put in late binding. All right. And early binding is what's done in C# at compile time. I'm going to explain all this in just a second. All right. On the other hand, let me get that back. On the other hand, with late binding, that's an example, for example, JavaScript, and that's at what's called runtime. So what's the difference? When something is early binded, like an array is in the language like C#, that means that at the time the program is being compiled, the system needs to know exactly how much memory to put aside. So it needs to know, for example, enough to hold 8 strings. It needs to know that, and that cannot change. If you're using a regular array, that cannot change as the program is running. Now, what's in here, just like I moved out and other people moved in, etc., the contents of the apartment string array can change, but the size cannot change. In JavaScript, on the other hand, on JavaScript that we learned last semester, since it's late binded, you can change the numbers, so you can add and remove. I could make this array bigger or smaller. You cannot do that in C# with an array, but you can.
Mr. Scott.
Yes.
Sorry to interrupt. James Wharton just messaged me. I just didn't want to tell him the wrong thing. I'm sure you're at home. Is the school shut down today?
Yes, it is.
Okay, thank you.
I haven't sent them out the thing yet because I was up trying to get everything ready for class. But yes, it is. You should have gotten it already. But yes, yeah. If you can tell them that, I'd appreciate it. Thank you.
Okay.
Tell them to feel free to send it out to the other 4 people in the class too.
Okay. All right. Thank you.
Thank you. All right. All right. So again, with JavaScript being late binded, the array can grow and shrink as the program's running. With C# being early binded, it cannot. Now, JavaScript is not the only one. I can use, so this is a C# array. One of the things we're going to learn about in just a bit is a C# array list. That, like JavaScript, can change as the program's running. All right. Only one more thing I want to say, and then we're going to start. Okay, we're going to start going through the chapter, and that is I can make an array of any of the types we've talked about so far. So I can have an array of strings like I just showed you. I can have an array of ints. I can have an array of doubles. I can have an array of decimals. I can have an array of booleans, etc. So all of those major data types that we've discussed thus far, I can have an array of those. All right. Not only that, all right, you can't mix and match, but you can create what are called parallel arrays. I'm going to show you that in a program in just a little bit. Now, I'm not even going to ask if all that made sense because it very well might not have. Really, in this chapter, in my humble opinion, all right, you're going to need to read this chapter for this to make sense. All right. But going back to the book now, it says arrays and collections are objects, but they're basically, as it says, they're containers. All right. It says, as you develop C# applications, you'll find many uses for arrays and collections. Virtually every programming language that I've ever worked with allows you to use arrays. All right. So it says in this chapter, you learn the basic concepts for working both with arrays and with collections. If you look in here, what you'll notice is starts on 224, ends on 266. So it's about 40 pages. Now, the first 26 of those 40 pages, so 224 to about 250, are just on arrays. That's what we're going to concentrate on mainly this morning. All right. And then tomorrow we'll finish up the last 10 to 15 pages. If we have time today, we'll get into this, but we'll just see how it goes time-wise. All right. Okay. The array that I described to you, this apartment array, is an example of what's known as a one-dimensional array. In other words, it just had 8 different things. Boom, they went from top to bottom. That was it. You can have arrays of multiple dimensions. In just a couple minutes, we'll talk about a 2-dimensional array. And when I talk about those, a lot of times people get confused and they're like, I don't understand that. Well, if you've ever seen a spreadsheet before, so if you've ever looked at Microsoft Excel, for example, that's really a 2-dimensional array. It's got rows in it and it's got columns. All right. You can make a 3-dimensional array, and you can even have more dimensions than that. Most of the time, you don't have more than a 3-dimensional array because it's hard to create an array that you can't fathom where you couldn't draw it out. All right. I tell this bad story, and people think it's, that I'm making it up, but I'm not. Many years ago, when I first started teaching at a college in Wisconsin, we were talking about arrays. And I said, your assignment for this weekend is to, I want you to draw out for me, to draw a 4-dimensional array for me. Well, I had people, were emailing me over the weekend saying, I don't know how to draw in 4D. It was a joke. It was a bad one, but it was a joke. But you can have a 4-dimensional array if you would need to do that. So I've shown you a bunch of this stuff already. All right. So you can do this and do decimal bracket totals, but before you use this, you've got to give it a size. You virtually never see it done like this, where this is done over 2 lines. All right, like this right here. You virtually never see that. It's always done like this. And that's what I tried showing you. Now, if there are 4 elements in here, this totals array, like you can see, that means that there are elements 0, 1, 2, and 3. The first element in the array is always element 0. All right. And the last element in the array is 1 less than the number of total elements in the array. So since this one has 4 elements in it, the last element would be 3. So you've got 0, 1, 2, and 3. All right. Now, I want to kind of quickly show you why arrays can be a really good thing. All right. So I'm just going to break away from this just for a second. I'm going to go back to here, but I'm going to move way up. All right. I have 7 people in this class. All right. So there's 3 other than the 4 of you here right now. And let's assume right now, all I'm going to do is I'm going to very quickly do this. I'm going to say int 1, and I'm going to do this. You'll see why in just a second, hopefully. All right. So I'm not putting names in here. I wouldn't embarrass anybody. And I don't, I'm not going to put, I'm putting mythical test scores in here anyway. But let's say that I wanted to do this. So I have 7 of you. Whoops, 7 of you. And I could do this. And I could come in here if this was my program, and I could say, please enter test score. All right, I'm not worrying right now. I'm not worrying at all about validating anything or writing exceptions. I just wanted to get a point across to you, and that's this. So please enter test score. Then I could come in here and say student 1 equals convert dot to int 32 read line. All right. And again, I'm not trying to waste my time here. I'm not trying to waste your time, but I want to draw all this out here. So this will work just fine. So this will be 7, 6, 5, 4, 3, 3 and 2. All right, and I think you'd all agree when we look at this. If I count the blank lines, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, about 21 lines. And it would work just fine. There's not a problem with it. Now, unlike me, for example, my counterpart, Mr. Corrigan, who teaches a beginning operating systems class right next to me in the morning, all right, he's got 25 people. So imagine now that rather than 21 lines, there were now 75 lines in there. All right. Well, that would work, and it would work just fine. Okay. Like I said, there wouldn't be any kind of problem with that. It'd be a little bit clumsy, cumbersome, etc. But let's talk about how we could write that using an array. So I'm going to say int bracket bracket students equals new int. And then we're going to say that there were 7. All right. Now I'm going to come in here and I'm going to do this. I'm going to write a for loop. So I'm going to say for int LCV, which is my loop control variable, equals. All right. And it equals, starts at 0. And its LCV is less than what we call here students dot length plus LCV. Now I'm going to come in here and I'm going to just grab one of these. All right. And I want to say here student LCV. And whoops, LCV. Come on, Jeff. There you go. So what do we have now? 1, 2, 3, 4, 5 lines. And the good news is, if this was Mr. Corrigan's class and he had 25 students, all he'd have to do would be to change that to 25. And it would still be 7 lines. All right. What I'm trying to get across to you is that basically loops work great with arrays. All right. So imagine I had 500 students. All right. I wouldn't want to do that 500 times. I could, but the chances of me doing that without making a mistake would probably be minimal. I'd skip one, I'd put the same number in twice or whatever. All right. So what this is doing right here is it's saying, I want to create an array of integers. All right. It will be called students, and there will be 7 of them. I'm sorry, 8 of them. All right. In fact, I do want to put in here 8. because it'll be 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7. No, it is 7. 0, 1, 2, 3, 4, 5, 6. Now, this is going to loop through this how many times? Well, the length is that number that's put in there. So it's going to be between 0 and less than 7. In other words, 0, 1, 2, 3, 4, 5, 6. That's 7 times. All right, so it's going to go through this 7 times. So 7 times it'll come up and it'll say, please enter test score. The first time through, it's going to grab whatever I put in there, and it's going to shove it into the first array location. Then it'll come back up to the top, add 1, say please enter the test score, do a read line, and shove it into the second array location. And it'll do that 7 total times. So when I got done, I would have something, for example, I'm going to make up numbers here, but if I said here, student 0 equals, let's say they got a 45, and I did this 7 times. I'll tell you what, we're going to pretend for just a minute that they didn't know, they all got a 45, but it's out of 50. All right. So if I did this and I entered in for everybody, for each student, I entered in a 45, that's what I'd have. But rather than having to put them all out one at a time, I can do it inside of a loop. All right. And that's what I want to get across to you, is the power of using arrays and the power of using arrays within loops. All right. Now, you normally use a for loop, or as you're going to see in a little bit, a special kind of for loop that's called a for each loop when you are working with arrays, because with an array, you know the size. That's right here. All right. So let me jump back to the book then. They give you a bunch of different type of array examples in here, and I'll let you read that yourselves. One nice thing about this language, and not all languages do this, but one nice thing is when you create a new array, like we did right here, when we did this, automatically, these all 7 of these locations, these were all initialized to 0. All right, so when you create a brand new array in C# and it's a numeric array, and you don't give the elements that are in the array, the different indices, a value, they automatically default to 0. And that's whether it's an integer array or a decimal array or a double array, etc. All right, if you create an array of characters, they're all given \0. What is that? \0 is the equivalent of double quote that we use for a string. All right. Boolean, they're all made false. Date, time, you can see that. Reference types, and what they don't show in there is strings, and strings are automatically all initialized to the empty string. So, as it says there, an array can store 1 or more elements. The length or size of the array is the number of elements that are in it. When you create an array, those are the default values that are shown right there. And you can change them at any time. But again, you cannot make, with a regular C# array, you cannot change the size of the array once it's been created. Like you can, for example, in a language like JavaScript, or you can, that we'll see later, when you use not a C# array, but a C# array list. All right, the smallest value in the array, 0, is called the lower bound of the array, and whatever the array goes up to is the upper bound of the array. Now, they mention this right here, index out of range exception, right there. And I just want to show you this, that if I were to go back to here, and let's say that I somehow, instead of saying less than, I said less than or equal to right there. Now it's, instead of trying to go through this 7 times, it'll try to go through it 8 times. Remember, the length is 7, so it'll do 0, 1, 2, 3, 4, 5, 6, 7. So when it tries to go through it that 8th time, it's going to blow up, because I've said there's only 7 elements in the array. when it blows up there, it's going to give me an index out of range exception. So that's another exception that we may have to worry about handling in our code. All right. All right. So they give you some examples in here. This is very similar to what I showed you. So they're creating the new array, then they're throwing values inside of it. And that's a decimal one, then they're creating an array and they're throwing some values in it, and those are strings. So again, you can either do it like that, or you can do it like I showed you if you know the values ahead of time. And notice these are all using brackets, but when you initialize it and give it values, all right, when you pre-populate it with values, you use curly braces. I will tell you this, the way that they show right here, this one, until we got this book, I never even knew you could do this. This first example that's right here. I have never done it like that in my life. I always do it like this because it's less typing. It's the only reason. All right. So here they're saying you can also use the word var, very similar to like the way we used var in JavaScript. And then what happens is the system will infer, oh, these are all whole numbers. This must be an array of ints. I'm gonna recommend you don't do that because there's really, I can't think of ever a good reason to do that. All right. So 0 is the lower bound of the array always. All right. The index of the last element in the array is the upper bound. All right. As it says, if you list the values to be assigned without using the new keyword, an array is created with a length equal to the number of values. So this automatically is going to create an array with 1, 2, 3, 4 values. This will be grades sub 0, grades sub 1, grades sub 2, and grades sub 3, for example. All right. Finally, as it says, and I just showed it to you, if you specify an index that's less than 0 or one that's greater than the upper bounds of the array, you'll get the array index out of range exception thrown. All right. So working with arrays, they're going to actually show you some stuff that you can use here. Now, I guess I screwed up. Notice they've got the name of the array dot length. Well, when I did it, I showed you this. That should have been an uppercase L. That's my error, and I apologize for it. All right. But when if you were to write this code and you said students dot, all right, what should come up in the IntelliSense, if you put an L in there, is one of the things that should come up is length. We'll check on that later when we write a program or two. All right. But they give you some examples. They even show you a for loop like I did. And now all they're doing in here is they're filling an array with the numbers 0 through 9. That's totally fine. All right. Now, some of the power in an array. Well, take a look in there. Here, what we're doing is rather than summing all those values up and saying, you know, again, imagine that instead of having just 8 or 9 totals, you had 8,000 totals. You wouldn't want to say sum equals totals sub 1 plus total sub 2, etc. You wouldn't want to do that. But you put it in a loop like this. This is the loop right here, up till that curly brace. This decimal average is not part of the loop. All right. But what's really nice about working with arrays, and you're going to see an example of this probably not till tomorrow, is when you want to do a lot of mathematical operations on a related group of data, it makes it an array is a very convenient place in which you can do that. And if you say, I don't get it, you're going to have to see some examples, I believe, before it'll start really making a lot of sense. All right. Now, as I mentioned, there's a special kind of for loop that you can use that's called a for each loop. All right. So why didn't I use a for each loop? I could have. All right. But typically, when you use a for each loop, it's because you want to go through the entire array that's already been filled in, and you want to do what's called iterate through the array. That's literally the way that you typically refer to it is I am iterating through the array, which means I want to work through the array. All right. Get rid of that. Okay. And bring that back up. Come on, Jeff. All right. But the for each loop is a little nicer because it's a little bit less typing for you to do. All right. So if we look at the example that's right here, this for each loop, okay, I'm going to show you this, okay, in the guise of what we just did here. All right. So they've got this thing with sum, it's fine, but I just want to show you that when you do this and you come through here, so let's say that when we got done, so we ran this program, and I'll make up values here. So 55, 76, 83, 12. This person didn't take the test, and this person got 100. All right, so let's assume we went through this for loop right here. And it said, please enter test scores. So we entered that one, then that one, then that one, etc. So we've entered these 7 different test scores. All right. Now what we want to do is we want to sum up the total of all those test scores. All right. Ways we can do this, and I want to show you them both. So let me come back down here. So one way we could do this is we could say sum plus equal students LCV. That is literally going to come in. That's as though we said 45, sum equals 45 plus 55 plus 76 plus 83 plus 12 plus 0 plus 100. I don't know what that number is. I don't care what that number is. Let's say it's 312. All right, so that'll put 312 in sum. And that works just fine. There is no problem at all doing that. But we can also write it, and I don't use for each a lot, so I want to make sure I'm giving you the right syntax. All right, so we could come in there and say for each, oh, not like that, we can't. For each, oh my goodness, for each. And we'd say, again, we'd say something like int total in, here we've got sum, let's change that to total. I want to use the number, what they used. So in total in, and we'll make this totals. Total, and now we're just going to put the same thing in there. Exactly what we put right here. All right, let me make this bigger so you can see them both. As you can see, this has 1, 2, 3, 4 lines, and this has 1, 2, 3, 4 lines. So what's the advantage? The advantage is the brevity of the for loop. This versus this. This is automatically going to create a brand new variable called total. It's going to initialize it to 0, and it's going to go through the entire length. All right. And in fact, even better than this, what we probably should, I could have done this a bunch of other ways, but the point is this. When you do a standard for loop, you initialize, you test, and you increment or decrement. With a for each, all you have to do is tell it what you want to iterate through. That's it. All right. Okay. So as it says, you can use for each to access each element of the array. You can also use for each to work with some of the collections we'll talk about later on in the chapter. All right. So next they say, let's talk about rectangular arrays. And again, a rectangular array is a 2-dimensional array. So if I come in here and I bring up Microsoft Excel, I just bring up a blank workbook like this, you'll notice that, for instance, this cell right here is called A1. It means that's in what? Column A, row 1. And you can even see, if you look right there, it says A1. So let's imagine for a second, I'm just going to throw in 6 values. So I'm going to put in here 12, 23, 34, and then down below this, I'm going to put in 36, 8, and 100. Okay? So if we were working in Microsoft Excel, we would say, hey, you know what's in here? It's in cell C3, cell D3, cell E3, cell C4, D4, and E4. Why? Because the way that you refer to this is the name of the column followed by the name of the row. You do it in the opposite way when you're working in programming languages. You give the name of the row first, then the name of the column. All right. So for instance, right here, if you look at this example that I'm circling right there, that one. And if you could imagine for a second, let me jump back into Excel. I'm going to remove all these. And I said go 4 by 4. There are 16 elements in there. So in Excel, that would be A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, and C4, and D1, D2, D3, and D4. On the other hand, if I'm working in C#, that is 0, 0, meaning that it's row 0, column 0. This would be 0, 1, meaning it's row 0, column 1, row 0, column 2, and row 0, column 3. This would be row 1, column 0, row 1, column 1, row 1, column 2, row 1, column 3. Row 2, column 0, row 2, column 1, row 2, column 2, row 2, column 3, and finally, row 3, column 0, row 3, column 1, row 3, column 2, and row 3, column 3. Now, you might say, that's fine. Why'd you waste our time doing that? Because it's important that you realize that when you're working with a rectangular array, a two-dimensional array, that this is how you set it up. You set it up in a row column order. That's as opposed to the way we looked at it in Excel, which was in a column row order. You can always tell how many elements will be in the array by multiplying the number of rows by the number of columns. So if it's 4 by 4, there should be 16 elements. If it's a 3 by 2, there'll be 6 elements, etc. All right. Now, notice that when you create an array like this and you do it this way, notice there's a blank, a comma, and a blank. Or you can just say just the comma in there. You need that comma because that sends a signal to the system that this array is going to have 2 dimensions in it. If you had 2 commas in there, you could make it 3 dimensions, 4 commas, 4 dimensions, etc. All right. But again, you have to realize that this goes in what's called a row column order. All right. Now, you might say to yourself, maybe you will, or maybe you won't. Okay, that's fine. Why would I ever use something like this? And I want to show you how you might use this. I'm going to come down to the examples I've been showing you, and I'm going to come down here. And I'm going to create 3 variables. So I'm going to say here int, and I'm going to call it hours, int minutes, and int seconds. All right. Now I'm going to write 3 for loops. So I'm going to say for int LCV. In fact, what I'm going to use here is H, M, and S. So this will be hours. So H equals 0. H less than or equal to 23. We're assuming military time. So plus plus H. All right. And in fact, let's come down here then. And now I'm going to put in another for loop. And this is going to be called M for minutes. So M less equals 0, M less than or equal to 59, plus plus M. All right, and you may have already guessed, what am I going to put in there? Yep, another for loop. Copy this. And this will be seconds. So why am I taking the time to show you this? Because we'll put this in after the break sometime. And I'm going to put in here, whoops, fix that. Right line. And let's say that I just put in here hours plus and a colon plus minutes plus and a colon plus seconds. And what you have right there in what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code is you can write an entire clock inside of these for loops. And it's going to show in there. Now it's going to look ugly because it won't be like 0, 0, colon. It'll be just 0, colon. But the point is we can make an entire clock, including our variable declarations, in about 15 lines of code. But yet, if you can understand what's going on here, you understand arrays. So in other words, this will be hour 0, minute 0, second 0. So the first time through there, this is going to run and it's going to look like this. 0, colon, 0, colon, 0. All right. Then when we go through it again, we're in this loop still. This is going to loop all the way until we get to 0, 0, 1. And I'm just going to put in here ... until we get to 0, 0, 59. Then it's going to go 0, and what? We're going to have to increment our minutes. 1, 0. All right. And that'll keep going till we've got 1 minute, 2 minutes, 3 minutes, etc. And eventually that will go to, I don't know why this is being so fidgety today. Eventually that'll go to 0, 59, 59. Then we will go to 1, 0, 0, and that will go all the way to 23, colon, 59, colon, 59. And the way that that's working is I keep going in here. I stay in that loop as long as the condition is true. All right. So as long as my seconds are between 0 and 59, I'm going to write them out. That's the 0, 0, 0 all the way through 0, 0, 59. Once I reach that point, now I've got a new minute. So I jump out of this loop and I jump into this one and I increment my minutes from 0 to 1, but then I go back into this loop and I do it again. So this will be 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, 1, 2, till we get to 0, 1, 59. Then it'll be 0, 2, 0, all the way till we get to 0, 59, 59. All right. Then we have to pop out of this loop and go back to this loop because an hour has just elapsed. So what I'm showing you, or what I'm trying to at least show you, is the way that this works. And this right here, we could do this. We don't need arrays or anything to do it. All right. But the point is, doing this kind of demonstrates basically the way that you work with arrays as well. If I've got an array that's got 3 dimensions and I want to traverse my way through it, I have the most outer on the outside, then the next most outer, and the most inner on the inside. So if I wanted to traverse through an array that's got 1 dimension, I do it in 1 for loop, like I showed you up here. If I had 2 dimensions, I'd have a for loop within a for loop, like this. If I had 3 dimensions, it would be kind of what I just showed you, etc. And if you can understand what's going on in there, you're well on your way to understanding this. All right. And if you go, well, I'm listening to you and I sort of get it, but not totally, hey, that's to be expected. All right. I get that. So as it says here, a rectangular array uses 2 indexes to store data. You can think of this as a table that has rows and columns. As it says, rectangular arrays are typically referred to as 2-dimensional arrays. It says, although it's rarely necessary, you can have arrays of more than 2 dimensions. All right. And then they're going to show you how you work with rectangular arrays. And it's exactly what I just showed you. All right. It's a for loop within a for loop. I'm not going to run through the example because I think the one I just gave you, all right, will suffice. All right. They are using arrays and I'm not. But notice it's a key thing here that you cannot use the same index name. Notice they've got I and they've got J. And when I did it, I had H for hours, M for minutes, S for seconds. I usually like to use LCV for the name of my loop control variable. If I was going to do that here, it would be LCV1, LCV2, and LCV3. Don't use the same name. It won't work. All right. Now it says there's a method that you can use that's called getLength that'll show you the number of rows that you have in an array or the number of columns if you don't know. All right. I'm going to go until about 5 after, then we're going to take our first break. All right. You can also create in C# what are referred to as jagged arrays. Well, a rectangular array means you have the same number of columns in each row. With a jagged array, you can have some rows have different numbers of columns than others. So we've got here what? This one would have 3 columns. This one would have 4. This one would have 2, etc. And why would you use that? It depends on what it is you're working with. In here, what do we have? Well, imagine these were just books. So we've got 3 book titles right here. All right. And these are movies. So we've got 4 movie titles, and these are songs. So we've got 2 song titles. All right. Totally fine to create. So this would be, they're all titles though. So we're creating 3 different arrays, and then we're sticking them all into their own array. And again, when you look at that, you might say that's really, really confusing. It takes a while to wrap your head around this. And again, I think you guys, other than Johnny here, have heard this, but I'll always remember the first time I really took a programming class, and the guy lectured for a couple hours, then he gave us a break, then he lectured for a couple more hours, then he let us go, and he said, now your first assignment, we were learning a new language. He said, your first assignment is I want you to go and read in an array of 25 numbers that you create randomly and say whether or not the numbers are prime. And there were students that were sitting around me that were like, that's it? I can do that in like 10 minutes. And I was sitting there thinking to myself, I had no frickin' clue as to what an array was. I had no clue. He did not talk about arrays at all in class to that point. It was the first day of class. So I went to the library, and that was back before we had the internet. So again, it's not like I could just sit there and Google it. I went to the card catalog and literally looked it up to find out what it was. All right. I survived. I got it done. I thought it was much harder than the other students in the class did, but I got it done. And you can trudge your way through it again as well. All right. So they show you how to work with jagged arrays. I don't think we're going to do much with jagged arrays. But again, the idea is you've got a different number of elements, all right, in each row. If you remember that, you should, for now at least, you should be fine. All right, before I go on and jump into 240, what we're going to do is we're going to take a break in just a moment, and when we come back, I'm going to write you a couple very simple programs, and I'll probably end up sending them to you by the end of the day so you can see them. But let me go in and, as always, set up my 10-minute timer. And I'll see you at 9:15. I'm going to refresh my water, so I'll be back shortly. All right, I am back. I hope you're back as well. And what I'm going to do right now is I'm going to start up Visual Studio, another version of Visual Studio. So right here. All right, and I'm going to create a new project. In fact, I'm going to create a whole new folder. Let me do that first. So I'm going to make a folder on my desktop that I'm just going to call, I don't think I have one that's called Arrays, but we'll see. So there it is, Arrays, right there. All right. So I'm going to come in and I'm going to first come in and say that I want a console app. And we're just going to call this, we'll call it Test Scores Console. All right. And I'm going to put it, let's see, where are we here? We are in this, the one we just created called Arrays. That'll be our folder. All right, so there it is, right there. And I'm going to call the solution test, how about this? Array examples. And again, you have to understand by now, this is the name of the project that I'm about to create. This is where it's going to live. And this is the solution because I'm going to create this project first as a console app. Then I'm going to create Test Scores GUI as soon as I get done with the console app. All right, so if I click create, I now have a folder that's called Test Score Examples, or Array Examples, I'm sorry, and it's got Test Score Console in it. All right, close that. So this is what we've got. All right, and I'm not going to put a lot of comments in here, but we'll put some stuff in here. So I'm going to try to make this simple. So I'm going to come in here and first say, in fact, first let's get rid of all this stuff we don't need, which is all that. And I'm going to have my using static system.console. And again, you don't have to follow along. I will send this to you at the end of class today. So these will be our declare and initialize program constants. Declare and initialize program constants. All right, and I'm going to have three of them. Const int min test score, and that'll be equal to 0. Const test int max test score. You've seen this kind of example before, and that'll be 100. And we'll have const int total students. We're going to set that equal to 10. So we're assuming that we're about to give a test. The people who take that test can get between 0 and 100, and there will be 10 people taking the test. All right. Hopefully what I just said made sense. All right. So now I'm going to declare my global variables. And I've got about 4 or 5. So I'm going to say here, static. And I have to make this static because all this stuff is going to deal with main. And since main is static, these variables here will have to be static as well. All right. So we're going to do that in just a second. So the first thing I'm going to do is I'm going to say static int bracket bracket. All right. Meaning we're making an array. We'll call it tests equals new int. Now what I could put in here, because we have 10 students, I could put in there 10. Totally fine to do that. All right, not a problem doing it that way. But what I'm going to do instead is I'm going to use this value that's in here. So I'm using a constant. And the reason I'm using that constant right there is if later I want to change that number, I only have to change it here. But if I made this 10 and I end up using that number in various places in the program, I've got to change it in many different places. Here I only have to change it in one place. So I'm going to declare here static int, and I'm just going to call this high score. I'm going to set that equal right now to -1. Oops, -1. And I'm going to have another static int low score, and I'm going to set that equal to 100. We'll go over it in a minute. And a static decimal for the average score. And I'm going to set that equal to 0.0m. Now, normally, because this is the way that I program, I would have comments in there for all that stuff, so you know what's what. I'm not going to take the time to do that right now. All right. What I'll try to remember to do is put in a couple comments here to explain what all these things are before I send it out to you later today. All right. So now we're ready to go inside of main. And we want to do this 10 times. And I'd like to have a fresh screen every time I'm doing it. So I'm going to start with a clear. And that just means that 10 times after I put this into a loop, I'm going to be able to clear the screen. So for each set of scores that each score that I enter in, and there'll be 10 of them, I will have a fresh screen. So I'll put a comment here that says loop through 10 times. I'm entering a test score for that particular student. Each test score must be between 0 and 100, which again, I called min test score and max test score. All right. Now, hopefully what I've just explained right there makes sense to everybody. All right. So what do I want to do here? Well, I want to enter in 10 test scores. All right. So I'm going to write a for loop here, and I could enter them in right here. But since I've told you about modularization, I'm going to try to practice what I preach. So I'm going to say for int LCV equals 0. LCV is, I could say either less than min test score dot length or just min test score, or I could say tests dot length. I'll just say min test score. I'm sorry, the num students. What do we call it? Total students. So I could either, I want to tell it to you correctly. I could either come in here and put in this, which is what I'm going to do, like that. Or I could say the name of the array, which is tests, dot, and notice the first thing it highlights here is length. So I could do that as well. Either one of those would work just fine. All right. In fact, since I got that in there, I'll just leave it like that. So what I'm saying here is I want to do something here 10 times. All right. So I'm going to say tests, which is the name of my array, LCV. So in other words, the current test is equal to, I'm going to get an error here because I'm going to reference something that I didn't write yet. I'm going to call input test score, and I'm going to pass it in that particular loop control variable. Now we're going to fix that in just a moment. But what I want you to realize is I'm about to call this thing, I'm about to call it 10 times. The first time it's going to be for student 0, the second time for student 1, the last time it'll be for student 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that'll allow me to input each one of my test scores. When I'm done, all right, when I'm done, I also want to calculate the following. The lowest test score, the highest test score, and the average test score. Right? So I'm going to just call this, I'm going to call another routine, and I'm going to comment that routine out for now, but I'm going to call determine test stats. That'll determine, I'm going to write one routine that's going to do this, and another one to do this, and another one to do this. Now, I could write it as 3 different routines or as one routine. Since it's only going to be a line or so for each one, I'm going to write it as just one routine. All right. Then when I get done, I want to display the following. All right, and it's the same thing that I want to display in here. In fact, I'll grab this. So I want to display the lowest test score, the highest test score, and the average test score. So I'm going to call this, instead of determine test stats, I'm going to call this display test stats. All right. All right. So let's write this one right here. Again, I want to say this one more time. Look at the comment. Loop through 10 times, each time entering a test score for that particular student. Each test score must be between min test score and max test score, or is 0 and 100. I'm passing this LCV, and the reason I'm passing that is I'm going to change this so it's, instead of saying enter test score for student 0, then 1, then 2, it'll say enter test score for student 1 through 10. If you say I don't know what you mean, you will in about 2 minutes. All right, so I'm going to write this routine now. So again, this is going to be, I'm going to say here, input each test score, validate that each score, all right, and I could do the is numeric, okay, and I guess we can. I'll do the is numeric. So is numeric, all right, and is between 0 and 100. In other words, our min and our max. So I'm going to write a routine right here that is going to do this. All right. Now, I'm not that stupid. I'm stupid, but I'm not that stupid. And what I mean is I've already written this. So hopefully I'll be able to do this without making any mistakes. So I'm going to do a static int input test scores. And when I call that before, I passed in LCV, and I'm just going to use that same name. It's an int, and it's called LCV. Now, as of right now, I'm getting an error. And I'm getting an error because it says I'm supposed to return an int, and I'm not returning anything. So for now, just so that error goes away, I'm going to type in return 0. I'll get rid of that later. But you notice when I did that, the error went away here. All right. And that should have had an equal sign. That's why I've got an error there. All right. So what should happen now, let's see what doesn't it like? It says the input test score. So now that all the errors should be gone. I'm not sure now why it's not giving. It says does not exist in this context. Well, let's see. That's in there. Input test score. Thought that was the same name. There. Now, not sure why it's still giving me an error. We're going to fix it. I'm not worried about it at all. So 10 times, I want to call this routine right here. All right. So let's write the code to do this. Well, you've seen before where I've come in and typed in bool result equal true. You've seen that kind of thing before. All right. And I'm going to have an int here that I'm going to call score that I'll just initialize to 0. Now, when I do this, I have mentioned this to you before, but I'm saying it again. All right. You will notice that if I highlight these, it'll say the variable is assigned a value, but it's never used. But underneath it, it says unnecessary assignment. In other words, it should be true by default. Well, I'm not taking any chances, so I am initializing both of those. Now, what I want to do in here, all right, is I'm going to put in a big loop so that I can read in the number and do two things. I want to make sure that the number is able to be parsed, all right? And I want to make sure, in other words, it's numeric, and I want to make sure also that it is between 0 and 100. All right, so that's what I want to do in here right now. Now, there's different ways that I can do it, but I decided to implement it because I haven't done much of these with a do while loop. So I'm going to put in here do. And down here, I'm going to put in my while condition, which will just say while, not result. So while result is false, I'll want to stay in this loop. Notice it's true here, but I might end up resetting it inside of my loop. All right, so I'm going to put in here, write, enter test score number. All right, now if I come in here and do this and I say plus LCV, it'll work just fine. All right, but it'll say enter test score 0, enter test score 1, enter test score 2, etc. I don't want that. I don't want it to start with 0. So what I'm going to put in here is LCV plus 1. I'm not changing the actual value. I'm just what's being printed out. Instead of printing out 0 through 9, it will now print out 1 through 10. All right, which is what I want, plus. And it's kind of nice when you're writing a program like this to let the user know what the heck it is you're looking for. So between test score plus and plus max test score. And we'll even put in here so it looks a little nicer. All right. Now you're not going to be able to see this for a little bit because right now we're saying while that's false and it's already true, but you're going to see what that formatting will do in just a couple seconds. All right. So now I should have a number. What do I want to do? I want to say result equals int dot try parse. You know what this is already. And I'm trying to to parse what I just read in. Read line. All right. And I want to send out to score, which is my variable right here. So this is attempting to take the number I just read in, ideally it's a number, and parse it to make sure it's an integer. All right. Now, if it fails, it's going to automatically, result will be set equal to false, and we'll break out of the loop. But if it succeeds, so now we can go down here and we can say if the score is less than our min test score, or our score is greater than our max test score, what does that mean? That means we entered a negative score or a score greater than 100. If that's the case, I'm also going to just say result equal false. Please play computer here. So what I'm doing here is I'm saying have user input test score. Let user know test score should be 1, 0, I should say, 0 and 100. All right, that's what we're doing in there. That's what this is doing right here. And if that was hard for you to read, then break it up over multiple lines. All right, so you can see what's happening in each one of these. Like that. So that should say enter test score for the first student. It should say enter test score number 1 between 0 and 100. That's what that's doing. Then come into here and attempt to parse inputted value above. That's exactly what we're doing. We're attempting to parse it. Result, which is a Boolean, is going to be true if it was a number and false if it was not. All right. And if it didn't work, score probably has nothing in here, but this will work fine anyway. So here we are, this is a range check on a numeric score. Again, 0 and 100. If it fails, set it to false. So I can set it to false either if I put in a number that's out of range or if I put in something non-numeric. All right. And now we can just return the score. Now, I'm going to save this and I'm going to run it. I do need, where are we in here? Somewhere in here, because it's going to go fly right off the screen, I'm sure. Let's see. Still not sure why I'm getting that, but we're going to fix that in a second. So I'm going to put a, whoops, on the bottom of this. After this, I'm going to put in a read line so it doesn't scroll off just go right off the screen. But we've got to figure that out because until we do, we're going to get an error here. Cannot apply indexing with bracket bracket on an expression. Okay, because I want to pass in LCV like that. That's what we want. All right, this is just a number. That's all LCV is. It's a placeholder. So the first time through, I'm passing in 0. The second time through, I'm passing in 1. The last time through, I'm passing it in 9. All right. Notice my error window is now clean. So file, let's save all. Now we're not doing anything with this yet, but it should run. So we're going to check. Well, notice enter test score number 1. If I leave it blank, it still says enter test score number 1. If I put a value that's out of range, it still says enter test score number 1. Another value out of range. There we go. So I'll put in 10 random numbers, 45. All right, number 2, 56. Number 3, 67. Number 4, 89, 87, 55. All right, 33, 22, 11, and 100. If I hit enter now the read line had kicked in, so I can just boom. So that's good. All right. Now, you'll notice that this didn't clear, so probably I'd want to take that clear and move it from where I had it to right here. Now each one of those, each time I ask to read a new test score, it'll be on its own. All right, it'll be on its own fresh screen. Now you'll notice it says my high score, my low score, and my average score right now, they're not being used. Test is, and that's why all of these are being used now, so they're blackened. These aren't being used, and the system is just telling me you've got 3 wasted variables in there. We're going to fix that right now. All right. What do I mean? Well, now we're going to call determine test stats. And I didn't do it like this in my example, but I am going to write it. Since there's 3 different things, I'm going to write it as 3 different routines. All right. So I'm going to call determine test score. And then I'm going to call determine high test score. And then I'm going to call, whoops, then I'm going to call determine average or just AVG test score. All right, I'm getting those errors because they haven't been written yet. I'm going to comment these 2 out and I'm going to write all 3 of them right down here. All right. Now they don't have to return anything and they don't need anything passed in. So these will end up being static void, each one of these. So static void like this, just like that. Now I can go and uncomment these 2. It's going to give me an error for just a second, but I'll just copy this one and put it in there twice and change the name. This will be determine high test score, and this will be determine AVG test score. All right. Now you'll notice I don't get any errors for any of those. All right. Now, what do I want to do in here? I want to find the lowest or the highest or the average test scores. And that should make sense to everybody. So let's do the lowest first. I'm going to have a thing in here. I'll create it and I'll call it int low score. In fact, I don't even need that. I'll just call it score. Int score equals 0. Then I'm going to loop through my array again. So I can grab that loop that I did before, or I could just rewrite it. But I'm going to grab this. all I'm doing here is I'm going to loop through or iterate through the array 10 times. And then what do I want to do? I want to say if the current score, which is tests LCV, that's my current score. If that's less than, all right, if that's let's see, if the current score is less than my lowest score, my low, what do we call it up here? I think it's low score, right there, low score. And since we set this, let's set it equal to 101. We'll go back in just a minute as to why we're doing it like that. All right. What do we know then? We have a new low score. All right. So I guess we don't need this. We can say low score equals test LCV. Again, we're going to run through this whole thing in just a second. All right. So when we get done with this, we now have our lowest score. Now, just to show you, I'm going to grab all that code and stick it right here. And all I have to change is the less than to a greater than and the low score to high score. All right. And now we've got both those. Now, I can explain those to you. All right. I can. But rather than explain them to you, I want to let the program explain them to you. And you say, what do you mean? I want to show you. All right. So I'm going to put a write line in here. And I'm going to put in here current test score. And I'm going to put in here tests LCV. All right, I'm going to put each one of these on their own line. Then I'm going to do another write line, and I'm going to put in current low test score. All right, and that is going to be what? Low score. All right, so plus. All right, and now I'm going to grab this after I've made the check, and I'm going to put this in here, and I'm going to say now low test score. So in other words, I'm going to, when I get done, I just showed you how we're inputting all 10 test scores. All right, we're calling that 10 times from right here. It's in a for loop, so we'll call this input test score 10 times. The first time it'll be for the first student, the last time it'll be for the 10th student. Once we get through all that stuff, then we're going to call determine low test score. That's again going to loop through the entire array. It's going to check to see whatever my low test score was, and I made it equal to 101, which is actually out of range. So whatever test score I read in there first should become my new low. All right. And I'm going to type in the current test score and the low test score. All right. And in other words, in fact, let me put in this twice. What we'll do is we'll take this one right here and we'll put it outside of the loop so you can see it every time we come through there. So we'll have the low, then we'll have the one we're about to check, then we'll have to see if we change the low, all right, etc. All right. So again, if that makes no sense to you, let me run it and hopefully then it will. So I'm just going to grab some numbers. In fact, what I'm going to do is over here, I'm going to show you just 10 numbers. And these are all random. 87, 23, 45, 76, 81, 20, 12, 1, 2, 3, 4, 5, 6, 7, 89, 100, and 48. So those will be my input values right there. All right, and I'm going to make this real small if it lets me. So I'm about to run this program. There's nothing special, like I said, about these 10 numbers. I just want to run them so you can see what's going on. So it says my first one, and this is going to disappear. Don't worry about it. I'll bring it right back. So I'm going to say in here that what I want to put in for my first test score is 87. All right, and I hit enter. All right, now, now it says number 2. Why isn't it showing me those right statements? Maybe I didn't save, so let's see. File, save all. It should have saved automatically, so let's see. Oh, because I'm not doing this till the end. Yeah, that's right. Okay, so let me run the program again, and I'm going to put in those numbers. Make this bigger so you can see it, and give you those numbers. So 87, then 23, then 45, then 76, then 81, then 20, then what? 12, then 89, then 100, and then 48. And hit enter. All right, and hit enter again. All right, now it says here, did it blow up? What did it do? Not sure why it didn't show me my stuff. I think, again, I'm going to have to go in here and put a read line in the bottom of this. I think that's why it didn't work. So let's check. So after all of this, now you might think, yo, that's fine. Why are you even doing all this? There is a reason. I'm going to take this stuff and all these write lines, I'm going to comment them out. If when we get done with this, you don't understand what's going on and I send you a copy, uncomment them and run the program and see if you can figure out what's happening in here every time. All right. That's how you learn. I mean, you don't learn by sitting there and listening to me as much as you're going to learn by sitting there and running actual programs. All right, let me try it again, and hopefully this time I'll get what I'm looking for. All right. Try it again. 80. 45, 76, 81, 20, 12, 89, 100. I don't want this 48 and 87 in here. So let's see. All right, do I have 10 numbers? I got 87 again. So 48. So I just put in 100 there and 48. Hit enter. Hit enter again. All right. Now what it's showing you here is what's going on. So when we first came in, let me make this smaller, but then I'll make it taller. All right. So when we first came into this, the current low test score was 101 because that's what we set it to. The current test score was 87. All right. So the new test score became 87. Then we run through it again. And now the current test score is 23. Well, it compares 23 and 87. We've got a new one. Then it does it again, and it's got 20. Now you'll notice it's only showing this stuff. So here was our low. Here is our low. That's not a new low, so it doesn't show that. Doesn't show that. Doesn't show that on here. Does show that. Does show that. Does not show these three. But it's running through in there every time, and it's showing you what is being compared in there. All right. So I'm going to comment these out for now. And now I'm going to come back in. And I'm going to put these back in but I'm going to have current high test score. And I'm going to copy back in this same stuff and then change all the lows to highs. I think I changed them all. So let's see, high, 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 high. Okay, so let me stop the run. Let me save this and let me run it again using, again, my same 10 numbers. So this is my test set right here. So I'm going to run this again, and I'm going to do the exact same thing that I just did. All right, so over here are my numbers, right there. Okay, I wanted to move that over, but that's fine. So I'm going to put in the same numbers, 87, 23, 45, 76, 81, 20, 12, 89, 100, and 48. I'm not going to hit enter yet, but this is where you can start playing computer. Originally, the low test score is going to be -1, so it should be replaced right there with 87. That's not more than 87, so it won't touch it, won't do anything, won't do anything, won't do anything, won't do anything, won't do anything. Oh, we got a new high. So it should replace the 87 with an 89. Yep, should replace the 89 with 100, and that should be our high when we get out of here. Let's make sure that's what happened. All right, I didn't put the read line in there again, so I screwed up. So we'll fix that. All right. Well, I missed one, so that's fine. I'll just put in here 34. All right, so you can see what's going on. It's 80, it got changed to 87. That stays until it finds 89. That stays until we find 100. And again, I hope that you don't think here I'm wasting your time, because I'm definitely not trying to do that. But I do want you to see what's going on here. That's my inspiration, so to speak, for doing this. All right. Then finally, I've got my last routine that's called display. Now, I could rate this as 3 routines. This I am, because I'm just displaying 3 things. All right. So I'm going to write that as 1 routine. So that'll be down at the bottom here, static void. Oh, I didn't do my average yet. We'll do that first. So static void. This will be display test stats. All right. But we got to do our average first. Well, remember, we can now go through this, and I can come in here with a variable. So I can say, whoops, I lost a curly brace. So I can come in here with a variable that I'm going to make an integer, and I'm going to call it sum. And I'll say equals 0. I'm going to change that in just a minute. So I can come in here and say sum plus equals, all right, tests LCV. And that'll add all of these test scores. So again, that's as if I went in there and said 87 plus 23 plus 45, etc. All right. The problem is now I can come in and I can say average test score or average score equals sum divided by, and I've already got my thing that's called total students, so that'll divide it by 10. But that's an integer divided by an integer, so that will throw away any decimal component. An average score is a decimal. So how do I get around that? Well, the easiest way is, I mean, I could come in here and just cast this, so I could put in here decimal, and that'll work just fine. I could put it there, or I could put it here, or as you can see, I could put it in both, and that'll work just fine. That'll work. It'll do everything I want it to do, but I can make it even easier than that. And that is, even though I'm adding 10 ints, there's nothing to stop me from putting that into a decimal. So I'll have to make it 0M. So now my average score should have that. All right. So before we, let's actually do this one, because it's just going to be the right lines. So right line, low test score, and that'll be low score dot to string. All right. And then let's do the high and then the average. So the high test score, whoopsie. And that'll be the high score dot to string. And then finally, we'll have the average. All right. And that'll be AVG. But since we went to the trouble of making that a decimal, I'll make that an N2, the 2 decimal places. All right. Now, with all that done, I'm going to do a file save here. And I'm going to run the program again. And when I do, I'm going to bring up my same test set that I've got right there. So make that a little less wide. There we go. All right. So 87, 23, 45, 76, 81, 20, 12, 89, 100, and 48. Enter, enter, enter. All right, again, stupid me. I need a read line after this. And I should be able to now get rid of all those other read lines that I put in here. I'm just going to comment them out. So if you want to go and run this yourselves later, you'll be able to do that. So I think there's one up here too. Nope, that should be it. So, all right, one more time. So, 48. Now, I'm going to hit enter, and it should say the low score was a 12. The high score was 100. Let's quickly just add these. This would be 110, 155, 231, I believe, 312, 332, 345, 445. It's going to be approximately something like around 600. So the average score should be around a 60. All right. So 12 was our low, 100 was our high, and 58.10 was our average. Okay. So I'm going to keep that because I'm going to rewrite that in just a bit, and I'm going to rewrite this as a GUI. All right. But what I'm concerned with, and again, I'm throwing all sorts of stuff at you right now. I get that. All right. And I'm not saying, yeah, I'm throwing all sorts of stuff at you. Do you get every bit of it? All right. But conceptually, as far as what we're doing, is there anything that I went through in here that didn't make sense to you? Anybody? All right. Now, I'm going to go back then and I'm going to build the interface and I'm going to rewrite this as a GUI app. All right. And what's neat about it, I just want you to know, is, for example, if I've got a button in there, let's say I've got let's say now I put in a button that says determine stats, for example. I can literally grab my determine low, I can grab my determine high, and I can grab my determine average. Do I have to make any changes? Let's see. If I do, there won't be very many. They'll be very superficial. I, of course, won't want read lines in here, but for this display, if I replace those write lines basically and just put it into a label or whatever, what I'm trying to get across to you is I've already got a lot of the program written for putting this in as a GUI program. All right, so let's stop the run here. Always make sure, because it's just a good idea to do a file save all before I get out. So I'm going to do a file and I'm going to type in here. In fact, I'll just close this one. So what do we got here? Whoops. I've got that right there. So that's my first one. Now I'm going to write a GUI one. So again, I'm going to click on my solution. I'm going to right mouse click and choose add new project. I want this to be a Windows Forms app.net. All right. The last one was called Test Scores Console. So I'm going to call this Test Scores GUI. All right. It's already in the right place and it already has the right framework. So I'll click create and there it is. All right. So now I can come in here and I can do very similar to what we've done when we've created our GUI apps as a class before. And that is, I can come in here and I can put in a button. Copy it a couple times. All right. And I'll just do them. I'm going to do these very incrementally. So this could be btn calculate. And of course, they spell. All right. And I can put in there for my text, calculate. All right. And this one can be, the text can be clear. And I can put in there for the name, btn clear. And finally, this one I can call btn exit. And I can put in there the text exit. That's all fine, no problem. Go here, highlight all of them. And I'm going to come in here and change my, as I always do, change my size. Let's make it about 18. That should be big enough. Bold and Arial. Boom. Now my buttons are done. That's good. All right. Well, what else do we need? Well, you know what? It would be nice. We didn't do this in the last program, but it would be nice that as we read in a test score, we put them on the screen so the user could see them. Hopefully you understand what I'm saying. It would be nice to do that. And that's what I'm going to do. So I'm going to make this wider. I'm going to pull this down. And I'm going to create a control we haven't talked about yet, but we'll talk about a lot in the future. And that is something that's called a list box. And why am I putting in a list box? Because it's going to list all 10 of those numbers for us. All right, so in here, if we've done it right, and if there's room, I'll have the 10 numbers. And I'm just going to call this LST for list box, LST numbers. And notice when I put that in, this changes, it actually puts in there the name of the control. So that says LST numbers. That'll be gone. That'll be gone when the program runs. All right, so that'll be my list box. This will hold my 10 numbers. All right, I also need what? Well, I'm going to need a label here. All right. And I want this to say, this will be LBL, low test score. And it'll have the text on it, low test score. All right. Then I'm going to copy it twice. And I'll want to put in, I can really move these around so I get a lot of room here. There we go. All right, so my low test score, and that's set. So this one will be LBL high test score. And again, I will just, let me grab that text there. Well, I can just change it to this. I'll just put high. So that's high test score. All right, and this one will be LBL AVG test score. And we will put in here AVG test score. All right, so I've got all those. I'm going to highlight them as I always do. And we're going to come in here and I'm going to set the text align to middle right. And I'm going to set the size of these. I think we said the last one was 16. It might have been 18. It does not matter. 16 should be fine. There we go. So we've got those. All right. I could put colons after each of these. You get the idea. I also want to change this and I want to make this bigger too. So this one I'm also going to make 16 and bold and Arial. All right. So I've got all that. Let's do that and put colons in there because it typically is done that way. Got a colon there. I've got a colon there. And I've got a colon here. All right. Now I need my 3 text boxes. All right. There will be my first one. There is my second one. There is my third one. Okay. Let me move that down. All right. And again, let's change the size on these right away. 16 bold, Arial, boom. Okay, so that's done. These I can now move over so they look kind of nice. They're butted up basically right against here or close to it. All right, that doesn't look too bad. And I want to take this. I've now got the right size, but I also want it to be centered. So I'm going to set my text align to center. All right. As I always do in here, a couple more things. Let's change the name of the form. So I'm going to rename this form FRM tests GUI. Enter. Yes, I want to save it. So I'd put some kind of a comment there. I'm not worried about that now. That's fine. I'm going to change my color as I always do. All right. And these will all be read-only because they're going to be figured out by the system. So I'm going to make those gray by going to my read-only. All right, so I've got that. And let's set my tab order. There's really not much I'm going to have to worry about in the tab order, but view tab order. I want 0, 1, 2. All right, we'll make this 3, 4, 5, 6, 7, 8, and 9. That's all fine. View tab order. All right, let's set our accept button to calculate. And let's set our cancel button to clear. And let's set our start position to center screen. All right, so let's see. So again, that'll be my low, that'll be my high, that'll be my average. That's all fine. This will be the calculate that we want to do. We'll do that after the break. This will be the clear, and this will be the cancel. Now we've got to figure out what we want to do here. And what I mean is when we clear, what do we want to clear? All right, I'm just going to want to clear these right here, just these. All right, my low, my average, etc. In fact, for now, I'm not even going to put anything in clear. I might decide later I don't even need it. All right, if you say I don't know what you mean, in fact, let's do this. When we clear, we're going to clear this out, and this, and this, and this. So we're going to do it like that. All right. And if you say, what do you mean? You'll understand, I think, in just a couple minutes. So I want this to be modularized. So I'm going to call here clear the GUI. private void clear the GUI. And I'm going to say my three, well, let's start with the list box, lst numbers.items.clear. That's how you clear a list box. We'll talk more about that after the break. All right. Let's see, I'm sorry. txt, did we rename those? I probably forgot to. Yes, I did. So that should be txt low test score, txt high test score. So txt low test score, txt high test score, and txt avg test score. All right, we are going to take a break in about 5 minutes, just so you know. All right, so I can double check here and make sure, did I rename everything? Looks like I did. All right, so going back to clear, now I can say txt, come on, txt low test score dot text equals double quote txt high test score dot text equals double quote and txt average test score dot text equals double quote. Now there is no focus here. Okay, so that's done. Now for the exit, as we've always done, looks like I forgot to put in as, oh, that should be a. All right, so for the exit, I'm going to grab what I always do here. Which is right here. But because I want to modularize, I'm going to call this exit the program. It'll give me an error because that has not been written yet. So private void exit the program. All right, and there's that. The only thing that's operational right now is the exit the program. Well, gotta make that my active project too. Someday I'll remember to do that ahead of time. All right, so there it is. Okay, so I can't put anything in here because they're all read-only. Calculate hasn't been written yet, but exit should work. All right. I'm going to run it one more time, and I got a question for you because we're about to take our break. What's wrong with this program right now? Somebody's got to answer this question before we get our break. What is wrong with the program the way it's currently shown on the screen? Come on, somebody can at least make a guess. What aren't we showing here on the screen? We are not currently giving the user the opportunity to enter in test scores. Does that make sense to everyone? Right now, there's no mechanism. When we enter in the test score, they're going to go into here, but we're not allowing the user to enter a test score. When we want to output something, we use a message box.show. There is no equivalent thing in here in C# for inputting. All right. Now, so what do I mean? Well, if you remember, those of you, again, I don't mean to put this on you, Johnny, but who were in the class last semester, all right, we would use a prompt, and that's the equivalent of what we want to do right now is we want to do a prompt. We want to prompt and ask the user to enter in test score 1, test score 2, etc. We want to ask them to do all that. All right, there's nothing built into C# that allows us to do that. All right, the good news is one of the other languages that's available in .NET that's called Visual Basic has something in it that's called an input box, which is what we're going to use. And what that means is we're going to go and bring in something from Visual Basic into our C# program so you can see how that's done. Do you have to do that? No, I'm just trying to show you something that's available to you. That's the idea. So with all that said, it is now just about 10:15. It'll be 10:15 in 44 seconds. So what I'm going to do is I'm going to start your break and I'm going to start up again at 10:25. I will see you then. All right, I am back. The first thing I'm going to do is I'm going to grab these constants and the global variables that I used before from the other program. I'm going to copy them to the clipboard, and I'm going to go and put them in here. Now, when I do, I'm going to remove the word static from there. Need to be static. All right, and it's screwed up the way this looks, but I'll pretty it up. I went back and wrote a bunch of comments during the break in the console one that I did, but I want to redo this one. Now, as I mentioned, what I want to do is I want to come in here and I want to be able to use, I want to come in here and be able to use something that's available in another language, that's available inside of the Visual Basic programming language. That's what I want to use in here. All right. And so what I want to do, and it's not hard, but you'll have to watch what I'm doing. All right. And I realize that my screen on here, it's not going to look that big. I get all that. But if I come over here and I'm on my test scores GUI, right there, right there. If I right mouse click, so click on it to highlight it. Then if I right mouse click on there, and if I go down, oh, where is it? Try this again. All right. So if I go down about halfway, there is an add statement. And under add, if I go down a little further, we've done this before. That's how you've added a new something or other. But I'm going to choose reference. right there. So again, taking this from the top, I clicked on my test scores GUI app so that it was active. Then I right mouse clicked on it and I chose add and I went to reference. And it gives me, this is a whole bunch of junk I can use if I want to use it. Man, there's a lot of stuff in there. All right. I don't know what 90% of this stuff is, but I do know that right now I've got C# highlighted, but I want Visual Basic here to be highlighted. So if I take my mouse and I put it over by just 2 down from where I am, where it says Microsoft Visual Basic, and I click, and then I click OK, now it brought in some Visual Basic stuff that I'm able to use in my program. All right. And if you say, well, big deal, it is, and I'm going to show you why in just a second. But in order to make that available, I have to come up to the top and I have to add using Microsoft.Visual Basic. Now it's gray because I'm not using it yet, but I'm going to use it in just a moment. All right. So what I want to do is in my calculate routine, you know what would be kind of cool would be if I could do the same thing I did in here. In other words, if I could come in and do this. Well, let's see if I can. All right. So I'm going to copy that. I'm copying this from the console program. And I'm going to try to put it in here into my program here. Now, clear doesn't mean anything. All right. So that is kind of moot for right now. So don't worry about that. But what I want to do is I want to call this input test scores. Well, we haven't written it yet. So we're going to write that right now. We're going to write input test score. All right. So I'm going to come in here and type in private. And this is going to have to return an int because it's going to be the test score. Input test score. And I'm going to pass in an int that's going to be LCV. All right. So notice that went away. I'm getting an error here because again, I'm not returning anything as of yet. I am not returning anything. All right, we're going to fix that right now. And you know what? Again, I'm asking you this question, kind of, wouldn't it be nice if we could come back to here and grab that routine that we put in, that big do loop, the bool result, and all that other good stuff, like right here, everything that was in there, that was in our input test scores. All right, in fact, let's start by grabbing the comment and putting the comment in here. And now I'm going to go back into here and I'm going to grab all the code that was in between the curly braces. And I'm going to grab it and I'm going to put it in here. And let's see if it gives us any errors. All right, well, it doesn't like the word write because that's for console programs. And it doesn't like read line. Okay. But that's not bad because it looks like at least that's the only stuff we have to fix. All right, so let's fix that now. Instead of write in here, we're going to put in, I'm going to create something in here, another variable. This is going to be the score. But when I read it in, it's going to be a string. So I'm going to make a string variable that I'm going to call score str. It means score string. It's going to be the same thing that I read in, but it's the string variable that I'm going to attempt later to convert that. I'm going to attempt to convert it into my actual score. Again, if you say, oh, I don't understand, just keep watching and hopefully then you will in just a minute. All right. So this is going to say our score str equals, and we have to say interaction, because that means that we want to call something from our Visual Basic dot input box. And lo and behold, if you look now, that error is gone. That's going to bring up a little box when we run this in just a moment. And that box is going to say, enter test score number 1, for example, between 0 and 100. Exactly what we just did. So what else do we have to do? Well, we want to attempt to try to parse that, but it's not read line that we want to parse. It's score str that we want to parse. So I made two changes. I changed this and I changed that. All right. Other than that, I'm using everything I had from the other example that we did before. And I'm going to do a file, save all. I'm going to try to run it and see if right now what it does. All right. I'm going to click calculate. Enter test score 1 between 0 and 100. I didn't verify before that if I put in something invalid that it didn't take it. So let's leave it blank. And it still says enter test score number 1. How about if I put something non-numeric? And it still says enter test score number 1. How about something negative? And it still says enter test score number 1. How about something out of range? On the high end, 101. And it still says it. Well, let's go back to our handy dandy things that we were using before. All right, the same values. So, unfortunately, it will stay there good. 87. Now notice it says test score 2. 23. Then it asks for 3. 45. Then for 4, 76. Then 81. Then 20. Then 12. Then 100. And finally, 48. Now, I must have missed one, but that's fine. It doesn't do anything with them yet because we haven't told it to. But we're now able to read in our 10 test scores. So what do we want to have happen when we read in these 10 test scores? Well, one thing is we want to add the current score we just read in to our list box over here. All right. Hopefully what I just said made some sense. All right. But let me do an exit and exit. Couple things because we're going to do that right now. But before we do, first of all, let's see. I'm going to make this. I'm going to make this a little bit longer like that. And I'm going to bring these down. All of that. All right. About there. Why? Because I want to come in and I want to put a label here. And this will just say on it, LBL test scores. All right. And this will just say test scores. It's kind of nice if I'm going to be putting something here like this to at least let the person know what this is that I'm trying to show. Make this a little higher. No, it's not letting me, and I don't know why. Shouldn't be locked. Now it is. Now it should be unlocked. Now, hopefully it'll be big enough. All right. In fact, let's lock all this. Let's lock our interface into place because I didn't do that before. All right. So now every time that I come in here and right before I return that score, I want to add that score. Add score to list box. And it's pretty simple. All I have to do is say the name of the list box, LST numbers, dot items, dot add, score string. And it's the score really, dot to string, or I probably could have just put in score string. All right. So why am I getting, put in my semicolon. And let's see, let's try running it again and see if it actually puts those 10 scores in for us. So save all, let's run it. There it is. Let me grab my numbers here. All right, so click calculate. 87, you can see it's in there. 23, 45, 76, 81, 20, 12, 89, 100, and 48. Oh, and we got plenty of room for them. Good. I can even make those numbers bigger. One thing that's goofy, and you can look this up online for yourself if you want. It's very hard to center stuff that's in a text that's in a list box. All right. You can do it, but you got to do some fidgeting. So mine won't be actually centered. All right. So let me click clear. Hey, that cleared. That's good. So I know that works. And let me exit. Last thing I want to do here quickly is I can make these numbers bigger. And I'm going to do that. So I don't know if this will be too big, but I'm going to change that from 15 to 20. If it's too big, you're not going to be able to see it in here, but that's fine. We'll just leave it like that. Okay, so what else do we want to do? Well, after we calculate, let's go back and look on here. What did we do? This is again, this is the console version. So after we calculated, and did I copy that in there? I don't remember if I did or not. No, so let's put in that comment. All right. So input each, yeah, I got all that. So what did we do next? After this, we call these routines. We don't need a read line, of course. We need to calculate all those. So we've got all those determines and those displays. All right, so bring that in. I'm going to get a bunch of errors, which is totally fine. Because none of these routines have been written yet. Oh yeah, they have. They're over here. So I'm going to grab these. I'm going to have to get rid of the word static and replace it with the word private. Whoop, not that one. I've already got that one. So there's my determine low test scores. There's my determine, oh, did I skip the high? No, I've got low and high and average and display. Now there's going to be errors in here, I'm just telling you, but it shouldn't take long to fix them. So let's come back down to here. And above our clear button, I'm going to paste that in and then start making changes. All right. So let's see what we have to change. I'm just going to take it from the top here. All right. So what do we have here? Determine low test score. And we've got tests.length. It says an object reference is needed for the non-static field. All right. Changing that to private. Wow. Almost every, looks like just about every error that was in there went away. Right lines no longer make sense. So I'm going to remove those. Read line doesn't make sense. So I'm going to remove, oops, come on, Jeff. Read line no longer makes sense. So I'm going to remove that. And you'll notice I've got no other errors in here. I'm going to change this one again to private. All right. I'm again going to clear out my write lines and my read line. There's my average. All right. Again, I'm going to make that private. Right. And looks like everything else is fine. And finally, with this last thing, to display the test scores. All right. I'm going to come in here and set up a string, as I oftentimes do, and call it output string. Output str, and I'll set that equal to nothing. And then I'm just going to keep saying output str plus equals, and I'm going to bring all these things in here. Low test score, and I'm not worried, I'm getting errors, but we'll see if we can fix that in a second. All right. And in fact, let's just grab this. And we'll put it in there 3 times. All right, we don't need read lines anymore, but we will need to say in here something in just a second. So low test score plus low score, it says an object reference is required for this non-static field. All right, then let's look. All right, so low test score, high test score. Maybe these do have to be static. So I'm going to check on these 3. So static, static, static. All right. Did that fix those errors? Yes, it did. I don't need that right line, but this is output str. So that'll be the low score. Then we need the high score. And we need the average score. This will have to go to high. This will have to go to average. And again, we want that to be in 2 decimal places. So N2. All right. And then Well, what are we doing here? We want to say, let's see. In fact, we don't need an output string. No, we can just come in here and say this. We've got our 3 text boxes. I can come in here and I can say txt. Did we call it that? Let's double check. This is the low test score. And it's txt low test score. Well, that's good. Txt low test score dot text equal. It doesn't like it for some reason, but we'll see if we can figure that out in a second. All right. Txt high test score. And I know what the problem is already. Maybe you figured it out. That is, I need the word private there. And that fixed those. I need an equal sign here. And then finally, txt avg test score dot text equals that one. Get rid of the read line. All right, do I have any errors or warnings showing? All right, the name N2 does not exist, so I did that wrong. That's got to be in double quotes. That fixed those. It says low score is assigned, but its value is never used. Well, I am using low score, so and I am using all of these, but it's saying that it's never used, but it is being used. It's being used in these routines. So in other words, where are we? Input test score. There was our low. So we are using low score right there. All right. So I'm just going to live with these 3 things, but I want to run it and see if I get the same result I got last time. Again, now I'm running it in a GUI format. I'm bringing up my data again. So click calculate, 87, 23, 45, 76, 81, 20, 12, 89, 100, and 48. Again, play computer here. You should know the low score is going to be 12, the high score is going to be 100, and I believe, so 12 should go there, 100 should go there, and I believe the average was like 58.10 or something like that. All right, well, 12, 100, and 58 point. Well, I don't need this stuff. I've already got that in the label, so let's clear. Now my clear works. All right, and let's fix that and run it one last time. All right, so I don't need this. I just need this and this and this. All right. Let's run it one last time and see if we get our correct results, and then we're going to go on. There we go. There's our low. There's our high. There's our average. All right. What I'm trying to impress upon you doing this is the fact that logic is logic. It does not matter when you are running or writing a program like this. Really, it doesn't matter whether you're writing it to be used in a console format or you're writing it to be used in a GUI format. That really doesn't matter. We are doing the same thing. We did the same thing both times. You saw that I went in there and basically, for lack of better words, ripped off my own code. All right. And that's what I was trying to get across to you. So I've now gone in and built, all right, I've now gone in and built the same application, and I have built it twice, once in a GUI format, once in a console format, and it's in here in this folder called Arrays. All right, so there they are, test scores and console and test score GUI. I am going to zip that, and not this second, but afterwards in just a second. I don't know where to put it, but I'll find it. It's in here somewhere. There it is. And I'm going to email that to all of you, so you've all got a copy of that. All right. With that said, I'm going to jump back into the code, into the chapter, I should say. And let's pick it up. And I think we left off, we were on around page 240. All right. More skills working with arrays. All right. Now, one thing that you were told at the beginning of the semester is that C# is an object-oriented programming language. All right. And when we created a button and put it on our program, into our program, we were creating an instance of a button class or a button object. When we did, everything else, whether it's text boxes, labels, etc. Well, in much the same way, arrays are also part of what's called the array class. And what is that? Well, I'm going to go out here to docs.microsoft.com, and I'm going to come in here in the search bar and click in there, and I'm going to type in C# array class and hit enter. And it says arrays. So there's a programming guide. So if you say, still don't understand what the heck you were talking about, plenty of examples in there. But I'm going to go over here to array class. And the reason for that is I'm going to go over here, and on the side, I'm going to first click on properties. All right. And well, I guess I might have to go down here to do that, to show you what I want to show you. These are the built-in properties that arrays have. I'm not going to read any of them to you. The only one we've looked at has been length, that you can see on your screen. But it has a lot of other properties that you can look at as well. What I want to get to is here, the methods. All right. So, well, you'll notice there's some binary searches in there that you may or may not understand, but there's a bunch of those. And then there's a clear and a clone if you want to make what's called a shallow copy. There's a regular copy. All right. And there's a whole bunch of stuff. So in other words, if I keep going down, notice probably upwards of 100. I don't know, maybe not that many. It doesn't matter, but there's a lot. Just put it that way. There's a lot of these things. All right. So I'm going to close that and come back to here. So it says how to use the array class. It's kind of what I just showed you. All right, you can go out there and you can take a look. As it says here, what they're showing you on page 241 are some of the common. These are some of the common types of properties and methods that you can use. Notice the only property they give you common is length, which is what I talked about. All right. We're not going to look at these right now, but I do want to talk about this one. And again, this is more for the benefit of Donald and for Michael, all right, from last semester, because I may have given this example already. And if I did, sorry, but you guys are hearing it twice where the rest are hearing it the first time. All right. A few years ago, actually now it was quite a few years ago, during the summer, I was sitting at home and I was actually doing some work, but I got bored, so I put on the television and I started watching The Price is Right with Drew Carey. And he had a gentleman on there. He was an older guy, and he had 1 minute to guess the price of a refrigerator. And if he guessed it, he was going to win the refrigerator. So the guy said $700, and Drew said higher, and he said 701. And I thought, you're not going to win. In other words, when you think about this, let's just, again, I'll use these. I'll just keep that up there so I've got those numbers. let's say that it was a refrigerator, and I'm going to make up this price. I'm going to say it was $2,395. I'm just making up that price. It means nothing. So Drew says, hey, make a guess. So I say $1,000, and he says higher. Well, now I know I've just eliminated 1,000 numbers. All the numbers between 1 and 1,000 are now been eliminated. So I guess again, and I say $2,000, and he says higher. And now I know that there's 2,000 that I've eliminated. So I say 2,500, and he says lower. Now I know, after making 3 guesses, that the value of that refrigerator must be between 2,001 and $2,499. So in my mind, I'm going to say, well, half of that is about $2,250. And he says higher. So now I know that it's got to be between $2,251 and $2,499. So again, I break it in half, and I'll say, let's just say $2,350. $2,350. And he says higher. Now I know it's got to be between these two numbers. So I guess again, and I guess $2,400. And he says lower. Now I know it's got to be between these. Now I've really got it down. So instead of having a big thing to search through, and remember it was $2,395. I know now, all right, now I'm going to say 24. I'm sorry, this should have been a 23. 23. Well, hopefully you get what I'm doing here. So 2,300 and $2,499. So I come through here and I say 2,400, and he says lower. So now I know that it's got to be between 2,301 and $2,399. So I guess again in the middle, and I say 50, and he says higher. So I do it again, and I say 75. And he says higher, so I do it again, and I say 87. And he says higher, so I do it again, and I say 94. And he says higher. Now I know it's got to be either 23.95, 6, 7, 8, or 9. So I'll say 23.97. And he says higher. So it's got to be either 23.88 or 23.99. Forget that one. We're going to pretend it was 23.99. All right. So I guess 98, he says higher, boom, I guessed it. Now, why am I telling you that? Because what I'm showing you right now, what I'm showing you is what's called a binary search. Let's take another example, and let's look at a simpler one. All right, I'm gonna put a random number in between 1 and 100, and I'm gonna pick 63. There's no significance to that. So I'm told to make a guess, and I say 50, and I'm told no, it's higher. So now in one guess, if the number must be between 1 and 100, I've already thrown out 50% of the guesses because it can't be 1 to 50. So I guess again, and I say 75. And you say lower. Now I know after 2 guesses, the number has to be between 51 and 74. So I keep trying to guess about half of that. So I'll come in here and I'll say 62. And it says higher. So now in three guesses, I know the number has got to be between 63 and 74. So again, I choose a number in the middle. All right, and I'll say, let's just say 68. And you say lower. Well, now I can throw all these out, and it's got to be a number between 63 and 67. So I guess in the middle again, and I say 65. And you say lower. So I know that now it's got to be, all right, lower than 65. It's got to be either 63 or 64. I guess 64. You say lower. I guess 63. And you say you guessed it. All right. What I'm showing you right now is what's called a binary search. It's also called a halving search. HALVING. Because every time I'm guessing, I'm eliminating or trying to eliminate half the numbers that were in there. Why am I telling you that? Because in essence, that's what the binary search is doing. All right? Okay. So it says it only works on arrays whose elements are in ascending order. So it has to be in order already. So in other words, when we ran our program before, and we put in those numbers, when we put in these numbers, they weren't, whoops, get rid of that stuff. Those numbers were not in order. So we'd have to redo this so that they were in order. Typically, you will put them in ascending order. And if I do that, I'm not going to do it right now, all right? But if I did that, all right, and I was to look for a number, let's say that, for example, I did that and I was looking for number 16, all right? It would start at the top, you know, and I could say 16, and it would go here, and it would know what to eliminate, etc. All right, so that's what we're going to end up starting to do tomorrow, is working with some of that stuff. All right, so let me keep going. How to refer to and copy arrays. Copying an array used to be, pardon my French, a royal pain in the ass. Because what you had to do was you had to create an array, then put that array into a loop and copy each element from one array from the existing array to the new array. Now you can just say array.copy. Boom. That's one of the built-in methods. Much nicer. All right. And there's different ways you can do this. And they show some examples in here. So this might be the hardest thing for you to understand for what we went over. All right. An array is a reference type. That means it's a ref parameter. Remember those refs that we talked about? And we said with a ref parameter, you weren't passing a copy, you were passing the address of where it lives. When you pass an array into a method, that array gets passed in and you pass in the address of the first element that's in the array, so the beginning of the array. The reason that that's important is if you change the array inside of the method, if you change it, it's a permanent change. All right. And that's one of the things they get to in here. Now they talk about shallow copies and deep copies and stuff. I'm going to let you read that. I think it's kind of confusing to go over that right now. So for now, at least, I'm going to skip it. All right. How to code methods that work with arrays. All right. So we've already done a little of this. You've already seen how I could get the sum by looping through the array. All right. Here's a method that converts a whole bunch of things, however many measurements we have, from what? It converts it from inches to centimeters. All right. We did that manually before pretty much, but if we had a whole list, we could do that. So as it says here, to return an array from a method, you put a set of brackets in there. So in other words, when you return an array, that's the array right there. All right. But notice when you pass the array in, you have to say double bracket bracket. Don't worry about params yet. We're going to hit on that. But the point is, it's the type of the array and bracket bracket. That tells the system that it's an array. All right. To accept an array as a parameter into a method, you use the word params. It says if you want to pass two or more arguments that aren't grouped in, yeah, you can include the params. All right. It says you code this keyword before. We're going to look at that tomorrow. All right. If I forget, please tell me. All right. Then we've got the null conditional operator. If you remember, null means unknown. So what you can say here is you can use, where is it? There, that question mark right there. All right. What this says is the following. It says, hey, check first and make sure that this exists before you try to run toUpper on it. That's exactly what it's saying. All right. Before you attempt to run toUpper on this thing, check and make sure it's not null, because if it's null and you try to run toUpper, you're going to get one of those argument null exceptions that we talk about. All right. And you can check. So as it says here in the description, if you try to access a member or element of an object that contains a null value, I guess it's a different one. It's in a null reference exception. All right. So one way to prevent it, as it says in that second bullet, is to use an if statement to check for a null value. All right. The easiest way to do that is with this null conditional operator. That's that question mark. It's fairly new. All right, it says because it can cause a null to be returned, it says the variable that the return value is assigned to must allow nulls. And again, if you don't get that, we're just going to keep looking at examples and examples and examples of it. All right? All right. Next thing that's in here, I'm only going to go for a couple more pages, but the next thing that's in here, more ways to refer to array elements. All right? The first one, you can use something that's called the range operator. This again is fairly new, and you're going to see an example on the next page. All right, so let's take a look. Notice what this says. It says this is sales 0.3. So this says give me the first 3 values that are in there, 0, 1, and 2. Since it starts with 0, you can leave the 0 off. You might say, well, who cares? Imagine for a second, imagine that you had an array like we've just worked on with 10 test scores. If I only wanted the first 3, I could do this, or I could do this. All right, 0, 1, and 2. If I wanted the indices 6, or let's say that 6, 7, 8, 9, and 10, we could do that. So it's a shortcut that you can use. All right. So as it says, with C# 8.0 and later, and remember we're using 11, you can refer to an element from the end of the array by coding, and I didn't even show you that, the caret operator before the index. So there it is, right there. All right. You can also refer to a range of elements using the range operator, which I just showed you. All right. Now, you're just learning this stuff, and that's a hell of a lot to throw at you. To my knowledge, there won't be anything like the range operator, etc. on your hands-on test that you'll take. Okay. Now, what I want to do here is 2 more things, and I'm going to have you out of here before 11:30. How's that? The first is to tell you that tomorrow I'm going to pick it up right here, right there, on the how to work with collections. So I would strongly recommend that you at least read that, because that's the last 15 or so pages of the chapter. All right, we'll talk about that. But before we do that tomorrow, we're going to look at a couple of examples, and I'm going to show you quickly the examples that we're going to work with. I'll send them to you tomorrow, but I'm going to go back and redo them again tomorrow in front of you so you can see these. So you've seen this one now. I can close that, and I will send that to you in just a moment. But tomorrow I'm going to add 2 things into this, and then I'll send it to you again. All right, so let me see if I can find that in my mess that's here. Well, I think this is one of them. Let me find out. I'll run it. All right. So you'll notice, not a small program, 300 lines if this is the right one. All right. And I realize it might be a little hard for you to see, but if I click new numbers, it just put 25 random numbers in there between 1 and 100. There, I just added the numbers together. Here, I've got the average of the numbers. Here, you may or may not be able to tell, they're now in ascending order. Now they're in descending order. I can grab the lowest number. I can grab the highest number. I can search for a number. All right, so I can say is 60 in there. It's not found in, or 50. It was not found in the array. But I can search again for a number I know is in there, and I can put in 34. And it'll say it was found and where it was found. Now, where it was found is its original position in the array, not where it is right now. I can do the median. All right, which is pretty much my average. All right, and I can do the range. Well, what's the range? The highest number is 98. The lowest number is 4. 98 minus 4 is 94. Arrange 98 and 4 with a high. Yeah, 94. There you go. So we'll do that tomorrow. All right. And I'm going to have to make a couple changes to this one, but I've also written it to try to get you into the groove of doing this a little easier. I'm trying to show you the other one. There it is. So I've also written it as a console, but it's a little bit different. What do I mean? The same logic is in there, but it's a little bit different. You'll notice smaller, about 100 lines smaller than the other one. But when I run it, this is what happens. I'm going to have to make my screen bigger. It's got how to run the program, and it explains what's going on in here. I just put that in as a message box. Oops, that's the wrong one. Let me try it again. Array console, set a startup project. There it is. It won't have a message box at the beginning. All right, Jeff. Array console, what do I got here? Array GUI. Should be that one, I think. Oh, this was the test scores. All right, the point is this. I don't want to waste your time watching me search for things. All right, but I've got this written twice. All right, I've got it written once as a GUI and once as a console. So I'm going to go back to the same one I used today with the array examples in it. When I just put in the test score console and the test score GUI, I'm going to add 2 more programs in there tomorrow. That's the first thing we're going to do. Then we're going to go back in and we're going to look at the collections, which is the last 15 pages. We'll see where we are with time after that. All right. And we'll adjust the schedule accordingly. Let's suppose that it's about 10:45. I'm just making that up when we get there. So I'll give you a break, and then we'll spend about an hour going over the next chapter that's in here. And much of the stuff that's in the next chapter, believe it or not, we've already gone over, because it's how to work with dates and strings. You've done a lot of work with working with strings already anyway. You know how to format these. I showed you these earlier, how to format something for percent or for currency, etc. So it's a lot of stuff that we've already gone over. This is also a shorter chapter. So my hope is tomorrow we can do 3 things. Go over a little bit more difficult example that will go through what I just showed you, console and for both console and GUI, go through the rest of the chapter on collections, look at their collection programs that are in here, and then if time, also go over chapter 9. All right. So really what we could do, in fact, why don't we do it like this? All right. I'm going to give you 10 minutes and I will go longer today. I'm sorry, but I'm going to see if I can go through this chapter today. Then tomorrow we can just concentrate on the array stuff. So it is 11:10. Let's take 10 minutes and come back at 11:20, and I'm going to attempt in a half an hour then to go through this chapter. I think it can be done without too much trouble. So again, there's your timer. Come back at 11:25, please. Again, I'm going to refresh my water and then I'll be back. All right, I'm back. And just to show you real quickly, this is the one that we'll be going over tomorrow. For the console one, it's not very long. And when you look at it, this is what it's going to do. It's automatically going to give you an array of 25 numbers. It'll automatically sort them into ascending order, then show you the smallest one, sort them into descending order and show you the largest one, show you the sum and show you the average. All right. So we will go through that tomorrow. And after I go back and recreate it for you, again, I will send that to you. So I want to take a little bit of time to go over the next chapter in our book. Now, the chapter is on strings and dates and times. So I went out to docs.microsoft.com and I typed in C# string class. And there's your C# strings programming guide, which is going to have in there, again, it's going to have all of the methods in there, will be in there, and etc. So all the stuff that you need to work with this is going to be in there. And then I did the same thing for the date class. And there's also a time class. All right. And there's a whole section in here on working with dates and times. So as always, I would very much recommend that you go and look at the documentation if and or when you have any questions. So the chapter is on dates and times and strings. All right, it's about 20 pages long, 20 to 30 pages. So we're going to go over that, but I'm only going to stress the new stuff. All right. So when you create a new date and time, typically you do something like this. Date time, if you want to create them both. There's a date, there's a time, and there's a date time. All right, by default, as it says with the date time, you get the year, you get the month, you get the day, the hour, the minute, the second, all the way through a millisecond. All right. And notice there is a parse for your date time, just like there's a parse for the other stuff that we looked at previously. All right, integers and decimals, etc. All right. So here is a way that you can set this. So notice they're setting it, all we're setting here is the date. So this is January 30th of 2020. Here is that date and also the time, and it uses military time. So it is 2:15 p.m. All right. You can do this any way you want. And not only that, when you look right here, all right, it talks about some of the formats. Now, these are United States formats. These are things we're all used to seeing. The actual, unless it's changed in the last few years, it used to be that at least that the universal symbol for a date were periods. But I don't think that that's considered a valid date format anymore, at least by Microsoft. But it shows some ways that you can put in the same date here. And as it says, you can use the date time structure of .NET to create and work with dates and times. All right, to create it, you use the new keyword, and then you specify whatever date values you want or whatever time values you want. You can parse those also. As it says, if you would omit the time specification, it's automatically set to midnight. All right. And a date is stored as a 64-bit signed integer, and it represents the number of ticks that have elapsed. This is a special date. It's known, January 1st of the year 1. So this is actually a really huge number when you talk about the number of ticks since then. Do you have to worry about any of that? Not at all. All right. So notice if you set current thing to datetime.now, if I did that for today, it would say 2-3-2020 and 11:24 and whatever seconds AM. All right. When you do that, you can also go in if you want to or need to, and you can format. Notice there's a long date string, a short date string, a long time string, and a short time string. What's the difference? They're right here. So there is a long date, there is a short date, there is a long time, there is a short time. All right. You can get information about dates. Now, this may not sound that important to you right now, all right, but just so you know, when you talk about getting information, that's known as accessing. So if it's the first day of class and one of you arrives early and I don't know who you are yet, and I announce over the, over Teams here, and I go, "Hi, my name's Jeff Scott. What's your name?" All right. And it's Donald, and Donald goes, "Hi, I'm Donald Walters." Or Donald Waters, I'm sorry. I'm Donald Waters. Okay, now I'm accessing. I'm asking a question, you're giving me information. That's an accessor. When we work in other languages later, it'll be called a getter. All right. If it turned out that I had 3 people in the class named Donald, and I said, "You know what? I'm not calling you Donald. I'm calling you Don. From now on, you're Don. I'm going to have Donald, Don, and Donnie if I have 3 Dons." Then I'm basically resetting your name. That's called a setter. All right. So the reason I'm telling you that is when you're getting information, that's an accessor. All right. If you are setting information, all right, then it's called a mutator or a setter. Now, why does that matter? Because when you use a getter, all right, you're getting information. It appears on the right-hand side of an equal sign, and you're grabbing that information and setting it equal to something else. When it is a setter, then the thing appears on the left-hand side of equal sign instead of the right side. All right. And then they show you some examples. Again, this isn't that big a thing one way or the other. Performing operations on dates and times. Well, when you look in here, you'll notice multiplication, division, modulus make no sense with dates. The one you're going to use most of the time is add. When you use subtract, it's going to be typically because you want the difference between 2 dates. All right. But you might use add days. There's a lot of companies that basically have their system set out that the day something ships, payment is due 90 days. It's typically called net 90. So 90 days after it ships. All right. So you could do an add days where you would grab the shipping date and you could add 90 to it. All right. So as it says, it's add days, and then that's the number of days you want to add. Same with months, years, etc. All right. The subtract one is a little more hinky because there's more to it. All right. A time span they get into, that's not that big a thing. It's just basically how much time has elapsed. All right. Notice with date time, you can use the plus, the minus. You can check for equality, for inequality. You can check if one date is greater than or equal to, less than or equal to another date. Same thing with times. All right. That's it for dates. Strings. You can check to see if something starts with something or it ends with something. All right. So for instance, if I was going through a lot of historical documents, all right, and I wanted to check and see how many of them started out with, let's just say the way they used to talk, like heretofore, something like that. Or if it ended with, and that's the end, something like that. I could check for different strings. The other stuff that's shown in here, the index and the index of, allows you to check for a substring. What a substring is it's a string within a string. All right. If I decided that I wanted to write my own copy of the Constitution, the United States Constitution, and I wanted it to be gender neutral, I could go in there and I could look for every instance of the word he or him or his, and I could change it to they, for example. All right, that's checking for it. That's checking something for a string with inside of a string. If I start my check from the beginning, I use index of. If that'll find the first occurrence. If I use last index of, it'll find the last occurrence. If I'm checking for something that does not exist, it returns -1. So -1 means, hey, there was nothing that met your criteria that you were asked to do. You can do insert, which, as it says, allows you to returns a string with the string inserted at the beginning of a position. So if I wanted to change everything, if I wanted to add a word someplace, I could do that. You can pad, and you can pad left and you can pad right. Maybe you've seen this kind of thing before It used to be that, for instance, if I got a check for $1, let's say 73, it might look like this. They want to make sure that I'm not going to come in here and try to put other numbers in here, for example. All right. And so I padded this with 4 asterisks as an example. You can pad on the left like I'm doing here, and you can pad on the right. All right. You can remove some of this stuff that's in here, like using remove and using replace. It's almost, typically it's used with strings, as it says, and it's used almost like a word processor. So I could remove every occurrence of something, or I could replace every occurrence of one thing with another thing. Substring is much like the indexes of, but where these are searching for something, this typically, all right, you can use substring also for searching, but it could, rather than starting at the beginning and going to the end, you can just tell it to search part of a big string. The to lower and to upper we've already worked with. The trim we've already worked with. Split, all right, it says it returns an array of strings where each element, well, let's look at that quickly. If I said this, so if I created a string and I said string greeting equal, and I said, hello, how are you? Make it a little smaller so you can see all of it, boom. All right, so if I did that, and then I went in and I said greeting dot split, for example, and I say that the character is just a blank space, what that's going to do is it's going to create an array, and that array will have 5 elements in it. Element 0 will be hello dot, element 1 will be how, element 2 will be are, and element 3, I guess that these will be, they'll be lowercase, and this will be you. So that's also known as exploding in other languages, because you're taking one thing and you're exploding it into a bunch of other ones. You're splitting it up. All right. As it says, it gets to be kind of confusing because typically in most every one of these string methods, the first character is character 0, just so you're aware of that. All right. Then they give you a bunch of code examples that work with these strings. Again, take a look at these, and if you've got questions, all right, we are going to next week, not this week, but next week, we'll go through an example or two as we've been doing from both the labs and from the homeworks. I will look at the labs, I will look at the homeworks this week. All right, we're going to go back to where we're going to end this Wednesday stuff, that next week I'm going to give you homework on Monday, and it'll be due the next Sunday, and we're going to try to stick to that schedule from then on. All right, so there's examples of all the things I've just mentioned to you. All right, and more examples of the things, okay? Now, you might say, well, yeah, you're really shortchanging this stuff. No, I'm really not. We're going to look at examples, and we're going to run through some examples of this stuff. So if you still feel like you were cheated a little bit later, then you let me know if there's something that I didn't cover well enough, and I'll be happy to go over it again. All right. The parse and the try-parse, we don't really have to talk about this. We've already talked about how to do parsing. All right. Now they do mention there's a bunch of other stuff in here, different characters that are allowed. So for instance, if you say currency, and you try to parse something that's in a currency format, it'll allow for a $sign and for a comma, etc. So you can read all those if you want to. All right. How to work with nullables. We've talked a little bit about this before. All right. But again, as it says, when something is nullable, what you're saying is it can hold null. So it's really important that you realize, like this line right here, that line that I'm making, I'm just going to hold my mouse over it, where it says string question mark message equal null. That's not the same thing as saying it's equal to the empty string. The empty string is a value with nothing in it. Null is an unknown value. So as they say there, when would you want to use this? And they tell you 4 things. When you assign or pass a null value, when you assign or pass a null reference type, when you refer to a null reference type that may be null, and when a non-nullable field isn't initialized. Now that said, again, you might say, yeah, you're going over this way too fast. We're going to be looking at some examples of this. All right. String builders are kind of cool. Strings are mutable. What the heck does that mean? If I do this, all right, and I'm going to change all this right now. I'm going to say string name equals Jeff. Somewhere in the computer, somewhere inside of the computer at some memory location, where I don't know, but I'm going to make it up and I'm going to say at location 1000. All right, there's going to be the zeros and ones. Remember, that's all the computer understands. Let me make this 1122 or something like that. So the letter J isn't put in there. The zeros and ones, the machine language that the computer can understand. So it'd be something like 01010101, something like that. That would be the J. Why am I telling you that? Because when you do this, name actually points to that address. All right. Now, if later on in my program, so I'm going to put in here ... Later on in my program, they want my full name. So I say name equals Jeffrey. Then what happens is no longer do I have this 1123. It grabs another place in memory. So let's say it was 3456, and it puts that in there. Then it takes this thing that was at this location and it says, hey, I'm not using it anymore. So there's something that goes and runs that's called the garbage collector, and it says, oh, we don't need that anymore. So it gives up that memory. And if you don't get it, let's just put it, let's look at a more realistic example. All right. It's kind of like if right now where I'm based out of still is 751 Parr Road, and that's in Wentzville, Missouri. 63385. Now, if for some reason, and I don't anticipate this happening, but Rankin moved out. So this is Rankin Technical College. Wentzville. So let's just pretend that it moved out and they moved someplace else. We don't care where. But somebody else moved in there. Let's just say it's some car company. So it's Carl's Cars. They move in. And now they're in here. All right. The address hasn't changed. It's just what's held in the address has changed. And if Rankin moves, let's say that we get a lot bigger location, and then that's at 8123, I don't know, Pine Road in Wentzville. All right. So now we've moved and we're over here. Well, then what's happened is this. All right. And if you say, I don't get it, well, give me a second. The address doesn't change. What goes in the address can change. The way that strings work is strings are known as being immutable. So if I say string name equals Jeff, that gets an address associated with it. If I change name, so if name appears on the left-hand side of an equal sign later on in the program, and again, if I do something like this, then what happens is this basically, the system sends a message that, hey, we're not using that anymore, but at a different address in memory, it gets this. And you might say, well, why does that even happen? It happens for a very good reason, because there's a lot of stuff in different places in computer memory. What if it tried to go and grab and change Carl's Cars to Rankin Technical College, which is a lot bigger? There might not be enough room in memory, enough empty locations that it could hold it. So what I'm trying to get across to you is strings are what are called immutable. They cannot change. You can change where a string is held, but you can't change technically the value. On the other hand, string builders are mutable. So you can build and you can work with a string builder and then convert it into a string. And that's what they talk about in here. Again, is this the kind of thing, do I have to be really concerned with this? No. But I just wanted to mention it to you. All right. I will make sure that I will look at the homework this weekend, and one of the examples, if not two, that we go over will either be a date time example and or a string example and or one of those two or both. So if you think you're being cheated, we'll go over an example together. All right. You can format strings. You've done some of this. We have formatted C for currency. We have done N for numbers. You can also, if you want, notice in here, if I put this in and I put it in like this, where I've got the curly braces in here and I show this as the format. This says if it's negative, show it in parentheses. And there's other formats that you can use as well. There's formatting this differently than the way I've shown you, which is with the .to string. You can use string.format. Have a read on that. We'll go back and we'll do at least one of the examples that we do. We'll use the string.format so you don't feel cheated. All right, you can do the same thing with dates and with times. All right. And you can also work with interpolated strings. They're kind of neat. All right. With an interpolated string, and again, Clayton and Michael and Donald, you already have worked with interpolation, where you can basically, inside of a string, you can put a variable name in there. All right. And this is how you do it in this language. We'll do some interpolation also. All right. And that's it. So again, I do want to make sure you understand that when we come through here and we start working on this, we are going to, not tomorrow, but next week, we are going to do 1 or 2 examples, if not more, as a class. I'm going to look through these and figure out what we can do as a class and what to assign. I will let you know that on Monday of next week. All right. And then on Monday of next week, I will go over 2 to 4 examples. The rest of the period will be lab. Tuesday will be lab all period. Wednesday then will be a pretest. And Thursday will be our test. That pushes it over from the schedule I put out there. Tough luck. Then we're pushing it over. I want you to be prepared. All right. Just so you know what's going on. So last thing, tomorrow we will go over those 2 examples that I explained to you. All right. That is, we will go through 2 array examples. And we will go through them in some depth and breadth of coverage. When we get done with that, we will go over the section on collections. All right. And we will spend some time on that, probably a good hour, going over some of the examples that the authors have gone over. All right. If there's any time left after that, I will try to do this by tomorrow. That is, look at the homework, look at the labs, and figure out what I'm going to assign you, what you're not going to have to do, and what we're going to do together. All right. If there are no questions, and I'll be glad to take them if there are, but if there are no questions, I'm done 10 minutes early, and I will talk to you tomorrow. Anybody have any questions? Anybody? All right. Then I will talk to you tomorrow. I'll see you then.